Okay, let's start building this circuit on Tinkercad. So all we need, first of all, is a breadboard. I'll just pull that out here. And then we will need 2 power supplies. So let's pull one out here and here. So this is on the right side, I'm going to do 10 volts. That's what we should have. And on the right side, left side, I'm going to do 15 volts. The current doesn't matter. So I'm going to connect this to the top, positive to positive, and negative, negative to negative. All right, put this here. Same goes for this one, positive to positive, negative to negative. Okay, now we can take a look from, okay, well, first we have these 2 resistors in parallel, so we could go ahead and set that up first before connecting it to the circuit. I'll do 1 at 5 and 2 at 10. Perfect. So the first resistor is going to have a resistance of 3.5 kilo ohms. I mean 3.6, excuse me. Second resistor, 5.1 kilo ohms. Okay, and they are in parallel, which means I'm going to put this one end. So I think what would help actually if I brought up my old diagram here. So I drew these positive and negative signs, and I'm going to reference this diagram to help me keep track of my circuit in the future. So right now we have the positive side of the resistors, these 2 resistors in parallel, connected to the positive side of the 15 volts. And like I said in my last video, I like to connect positive to positive. So I mean, I like to set this side as positive. So left is positive. You could set right as positive. I think it might be, it doesn't really matter. Just for the sake of convenience, I'm going to do this positive. So we know that this side is positive for these 2 resistors. Okay, now this side should be negative. Yes, so what does the negative side of this connect to? Well, it connects to 2 other resistors. And so we need to put down these 2 resistors first, R3 and R4. All right, so let's put one down at 15 and call this R3, and one at 20 and call this R4. 1, 2, I think I accidentally put another resistor and deleted it, so 4. Okay, R3 has a resistance of 1 kilo ohms. Hold on, what? Is there a resistor here? That, okay. I don't know why it's, oh, okay, I'll just do this, R2, R3, R4, okay, perfect. R1, R2, R3, R4. Alright, so the negative side of R1 and R2 connect to, let's see if this is positive or negative, the negative side of R3. Okay, fair. So this is R3 and this is the negative side because we set this as positive. So I'm just going to plop this here. So that's connected to R3. And the other thing that is connected to is the positive side of R4. Okay, so this is R4 that has the resistance of, it should have the resistance of, oops, 2.5. Did not change that. Let's see if R3 changed. Okay, R3 is, yeah, R3 is 1 kilo ohms, R4 is 2.5. So negative side of R1, R2 to positive side of R4. Well, let me move this wire up. So I'm just going to move that here, and then I will connect that straight over here. Let's do that. Okay. So negative to positive side of R4. Perfect. Did I close? Oops, I closed it. Okay. Now let's see what other one we have to do. I think we have to do R5. Okay. Let's put down R5. R5 is the positive side of R5 is connected to the negative side of R4. So we take this R5 and the resistance is 2 kilo ohms. Now, what did we say? Net positive of R5 to negative of R4. Let me put this, just give it some space. Okay, great. Now, the negative side of R5 is connected to the negative side of the 10 volts. Okay, great. Negative side connected to negative side. And I'll just mark this as black. And then what about this 10 volts? The positive side of 10 volts connects to the positive side of R3. Well, where is R3? Here it is. And, aha, positive side. And this should close our loop because now everything... Oh, I forgot about the 15 volts power supply. Okay, let's check where this is connected to. So it's connected to the negative side of R4 and the positive side of R5. Now, these two have already been connected. Negative side of R4 connect to the positive side of R5. That's this node here. All I'm going to do is drag this, and I'll make a little detour here and connect it to the negative side. So now, following this diagram, we should be getting the correct currents. And let's see, the current we set for I1 is 3.01 milliamps, I2 is 0.45 milliamps, voltage is 10, voltage is 15. Let's see if everything works out. Alright, so it does look like everything is working as expected. Now we just need to check to make sure that the voltages are what we would expect. So let's take out our multimeter. Oh, we have it right here. And I'm just going to pop one down here. So we're going to start by measuring the voltages of each resistor. I would say it's easier to have multiple of these. Now in real life you'll only really have one or two at the max at any given time, but this is Tinkercad. So I'm going to connect negative to negative. Yeah, let's color code our wires just to be safe. Positive to positive. And let's verify the first resistor voltage is 6.35. Is that what we calculated? We did calculate that it was 6.34, but again, there must have been some calculation rounding errors. Now, let's just, instead of using all these multimeters, I actually prefer to use maybe 2 at max. So I'm just going to connect this wire to negative to negative. Oops. Oh god, this is awfully hard to click on. Positive to positive. So this is R2, and what did we expect for R2? We expected the same voltage because these are in parallel. So we should expect 6.35 as well. Let's see if we do get that. 6.35, and we do. Perfect. Now, let's do R3. 0.45 volts is what we calculated. So let's see. positive to positive. Just going to do this here. And negative to negative. All right. 450 millivolts, which is the same as 0.45 volts, just different prefixes. Perfect. Let's check R4. Oh God, please don't tell me. Okay. R4, positive to positive, negative to negative for black. 8.65, is that what we expected? Yes, it is. Perfect. Let's do R5, the last one. It should be 0.9 volts. This one, I'm just going to use this resist multimeter here. And we are expecting 0.9 volts. As we see 901 millivolts. That's the same. There was some decimal places that I didn't include. So it looks like voltages check out. Now we need to measure the current and verify that the current is the same as our calculations. So where should we place an ammeter to get the current for R1? Well, it should be, let's take a look. It should be right after it splits off, the current splits off, but before it goes through the resistor, or it could be right after the resistor, but before it joins up. So what should be the easiest? Well, I think it's easier if we do after the resistor and before it joins up again. So this is R1. So the current goes here, goes through this wire, and then it goes through R1, and then it comes back to R2. So I'm going to delete this wire and splice in my multimeter. Negative to negative, positive to negative. We might get negative signs. Oops. If we do, we'll just flip it. Oh, this is voltage amps. 1.76 milliamps going through R1. That should be what we are getting. 1.76 milliamps, and all I did was I flipped the wire, but as you can see, there was no errors going through that. There was no difference in magnitude. So let's do R2 now. For R2, it's actually easier to place the ammeter before it goes through the resistor. So let's delete this wire, and I'm going to place the multimeter down here. So now let's do it the other way. So last time we did positive to positive. Let's go negative to positive first. Black and red. This time we should be getting a positive number if we are measuring amperage. Oh, okay, I was wrong. 1.25 milliamps. Yes, it is still the same magnitude. So the only problem was that we needed to flip the wires. So let's see if we get the same answer if we just flip the wires here. Yes, we do. Okay, great. So now let's close the circuit back up to our original circuit. So we verified that the current through R1 and R2 is what we expect. Now let's do R3. So same reasoning, we either place it right before it goes to the resistor or right after. Let's look at our circuit to see which would be easier. Well, it might be easier to go right before the power supply. I mean right after the power supply, but before it goes to the resistor. And we see that it's connected through this wire here. So all we're going to do is delete this wire and take one end of this connected to R3 and connect the other end to the power supply. Remember that the bus strips down here are all one node. So this is amperage. Let's see what we get. 450 microamps. And R3 is I2, which is 400.45 milliamps, which is the same as 450 microamps. Now let's do R4. So again, delete this wire, connect it back, put everything back in its place, R4. So for R4, it could be right before it goes through the resistor or right after it comes out of the resistor. Let's take a look at the circuit to see which would be easier. Well, we could go either way. We could delete this wire or we could delete this wire. Just for the sake of simplicity, I'm going to go to this wire and delete it. So remember, one end is connected to R4, the other end is connected to R5. All we need to do, connect it here, connect it here. I'm going to label this as positive and negative. And what we should expect is I1 plus I2, and that would be about 3.46 milliamps. Let's see if that's what we get. Yes, it's a negative sign because I flipped it, but it's all good. Still the same magnitude. The last one is R5, and we should expect to get, what should we expect to get? I2, which is 0.45 milliamps. So same reasoning as the other resistors. We splice in the wire either before the current runs through it or after. We could do, I think it would be easier to just do after. So let's take away this wire. This is coming back to the power supply, right? No, hold on. Oh, wait. Wait. Yes, okay, so this positive end is connected to the 15 volts. So that's this wire, and the negative end is connected to the 10 volts. Okay, so let's delete this. And this is connected to the negative end. And this is amperage, so we should expect I2, which is 450 microamps. And yes, we do get that. So that is how you measure current and amperage, current and voltage in Tinkercad in more advanced circuits.